Hi guys. So I decided to post another video lesson on charging, the methods of charging. I know there was a few of you that were that needed a little bit more clarification, so I decided to add this video, and I hope this helps clear any misconceptions and gives you a better understanding. I also posted a video today, this afternoon, around 4:30 on electrostatics. And I know it was a very old video, but it's a very good video, and explains all the different methods of charging. So I hope that you guys watched it if you thought you needed to have a little bit more help. So more on electric charges, detecting electric charge and charging by induction. So we talked about charging by friction, contact, and now we're going to be talking today about charging by induction and permanent induction. So again, these are the different types of electroscopes that I've talked about before. So how do you know when an object is charged? Rather than testing whether objects stick to something else, you can also use an electroscope. And so an electroscope is a device that can be used to detect the presence of an electric charge. So on the left side, you have a metal leaf electroscope, and on the right side, the diagram illustrates a pith ball electroscope. So electroscopes are used to detect the presence of electric charge, two types, metal leaf and pith ball. So a pith ball electroscope is a light metal coated ball suspended on an insulating thread. And if the ball is negatively charged, it will be repelled by a negatively charged object and attracted to either a neutral object or a positively charged object. Because of the law of electrostatic charges, we know that like charges repel, opposite charges attract. So let's take a look, test your knowledge. Assume that an object is brought near but not touching a neutral pith ball. What are the possible outcomes if the object is positively charged? So we're assuming that the pith ball, this pith ball right now, is neutral, and if the object that you bring close to a pith ball is positively charged, will we see attraction, repulsion, nothing, or explosion? So everybody should have guessed that A is the right or correct answer. So if you have a neutral pith ball, anything that is charged, basically a positively charged object, there will be attraction because opposites attract. And if it's a negatively charged rod that's brought close to the neutral pith ball, there again will be attraction. So detecting electric charge. So a metal leaf electroscope consists of two thin metal leaves that are suspended from a conductive metal rod. We've talked about this. Any charge spreads out over the entire electroscope. Since the leaves are then charged, similarly, they will repel each other, therefore indicating the presence of charge. So you already know that the electrons will either go down into this rod that is connected to the metal leaves, and when that happens, the leaves both become negatively charged and they will repel each other. So these leaves will basically spread apart. And the same thing will happen if the electrons are pulled up the metal rod into the knob, because they're attracted to some negatively charged object that has been brought close to that metal knob, those leaves will also spread apart, because then they will become both positively charged. Okay, so if the leaves are charged the same way, they're both positive, there will be repulsion. If they're both negative, there will be repulsion as well. Therefore, this will just basically detect the presence of charge. So, for example, so when a negatively charged rod, this is a negatively charged rod because there's 1, 2, 3, 4, 5, 6, as opposed to only three positive charges. If this rod is brought close to a neutral metal leaf electroscope, the electrons in the electroscope will be repelled. So this shows now a positively charged knob, because the electrons were being repelled by this negatively charged rod. They move down into the metal leaf electroscope, and eventually into these metal leaves. So now these metal leaves they have a lot more negative charges, both of them, compared to positive, and they're going to be both negatively charged, and therefore they're going to repel each other. So the electrons move down into the leaves of the electroscope. Since the leaves are now both negatively charged, they will repel each other and move apart. So when the negatively charged rod is taken away, however, those electrons that move down into the metal leaves are going to move back up. So the negative charges in the electroscope are no longer repelled. So they move back throughout the leaves, through the stem, and back into the knob. So now you see that the knob is neutral again. There's 1, 2, 3 positive charges and 1, 2, 3 negative charges. If you look at the leaves, there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 positives and 5 negatives on both sides. This entire electroscope is now neutral, completely neutral. And therefore the leaves are dropped down and they're back kind of close together again. So what would change about the way an electroscope worked if its metal knob were replaced with a plastic knob? So these are the options. It would no longer work because plastic is an insulator, so the electrons would not move. B, the metal leaves would move apart or further apart. C, the metal leaves would fall off. Or D, the electroscope would explode. So all of you should have thought of the statement, the first statement, statement A. Basically, it's no longer going to work because plastic, if you replace metal with plastic, that plastic is an insulating material and therefore the electrons would not move. So they won't go down that metal rod into the leaves, and therefore these wouldn't spread apart. You couldn't have electrons moving at all because this is an insulating material. Okay, why do the leaves of a positively charged electroscope move farther apart if a rod with the same charges is brought near? Well, these are the options. Electrons in the knob are repelled by the rod and would move down the metal leaves. This would cause the leaves to become negatively charged, therefore separating them. Okay, so this is originally this knob is originally neutral, and if you have a positively charged electroscope, why do leaves of a positively charged electroscope move farther apart? So if you've already got this whole electroscope being positively charged, if this positively charged rod comes close, the electrons will move down the leaves even more and making them negatively charged. They would be separated more. Our electrons are attracted upwards to the positively charged rod, leaving an even greater positive charge on the leaves, causing them to repel even more. So which one would it be? So you see that this rod is positively charged, and this is a positively charged leaves on the electroscope. If you bring a positively charged rod close to that electroscope, more electrons are going to move away from those leaves because they're attracted to this positively charged rod. This will leave the metal leaves even more positively charged, and they would cause repulsion. Okay, so the answer to this question would be B. The electrons would not move down into the leaves. They would be actually moving up towards the knob because they're attracted to the positively charged rod here. A rod and electroscope have opposite charges. Why would the leaves move closer together if the rod was brought close to the electroscope? So why would the leaves move closer together if the rod was brought close to the electroscope? So the two options. Electrons in the electroscope knob would be forced down into the leaves, reducing the overall positive charge on the leaves, causing them to move closer together. Or B, electrons from the rod would jump from the rod to the knob and be forced down into the leaves, reducing the overall positive charge on the leaves, causing them to move closer. Okay, so the answer is A. The electrons in the electroscope knob right over here would be forced down into the leaves because they are going to be moving away from this negatively charged rod. And when they do that, they move into the leaves. These leaves now become less positively charged, and therefore they're going to be more, they'll move closer together because that force of repulsion will be less strong. Oh, and the last one, I didn't see this last option here. Obviously, protons cannot move, so C would be incorrect. So induced charge separation. So a charged object will attract some neutral objects. When a charged object is brought near a neutral object, it causes or induces the electrons to shift in position, and this is called induced charge separation. So the movement of electrons occurs according to the law of electric charges. So if you see this diagram on the left, the rod is negatively charged. There's 5 negative charges compared to 3 positive charges, and the pith ball is neutral. Okay, but when that rod is brought near the pith ball, the negative charges you see are going to, the negative charge on the rod causes some of those electrons in the pith ball to move further away from the side that is closer to the rod. And this results in a net positive charge on this side of the pith ball and a net negative charge on the other side of the pith ball. Excuse me, and this is called induced charge separation. So although there is a shift in the positions of the electrons in the neutral object, it is still considered to be neutral. Okay, so we know that this is definitely negatively charged because there's actually more electrons than protons. However, in this case, there are 1, 2, 3, 4, 5 net electrons and 1, 2, 3, 4, 5 protons. So it is overall, it's still a neutral pith ball. However, the positioning of the electrons changes, and this is why it's called induced charge separation. And once this charged object is moved further away from the neutral pith ball, the electrons will move back to their normal or original positions, and it will look more like a neutral overall charge. So there's induced charge separation, which can be temporary. So this occurs when a charged object is only brought near a neutral object. The electrons in the neutral object shift position, while the protons, they have to stay in a fixed position, and the entire object is still neutral. Near side becomes oppositely charged, and attraction eventually occurs. So because this is negative, this pushes the electrons to the other side. This side of the pith ball is positively charged. A negative will attract positive, and there will be a pulling towards each other. There's an attraction that happens, okay? This is because there's no contact. This is called a temporary induced charge separation. And I'm not going to worry about that. So objects can be temporarily or permanently charged by induction. And so this is another example of temporary. And there was a question in your homework about this. So when a charged object is brought near a neutral object, okay, so this is a charged object, it causes or induces the electrons to shift in position, resulting in an uneven distribution of charges. So you see here, again, you see a negatively charged balloon because there's a lot more negative charges than positive. This is a neutral wall. So you've got 1, 2, 3, 4, 5 positive charges, 1, 2, 3, 4, 5 negative charges. So exact same number of opposite charges. And when you bring that balloon close to that wall, what will happen is these electrons that were kind of randomly scattered will actually move away from that negatively charged balloon because they repel, and they will move further, as far away as they can from this balloon. And so this side of the wall becomes positively charged, and this side of the wall, the back, the closer, this part beside the further away from the balloon, becomes negatively charged. So this will only be temporary, as the electrons will move back to their original positions once the charged object, this balloon, is basically taken away. And then that neutral wall is going to look like this again. Now, you can permanently charge by induction by a process called grounding, okay? So when you charge an object permanently by induction, you use a charged object to induce the charge in a neutral object, like you did in the balloon and the wall. And then you ground the charged object so it retains the charge. And this is called charging by induction permanently, or permanent. So charged object induces the charge separation in the neutral object. The neutral object is grounded. So for example, the electrons will move to the ground, or move from the ground to the object. Okay, so this is basically where this neutral object is, it makes contact or some kind of connection to the ground, either by you touching it or you grounding it by some kind of metal material, metal rod that has some kind of connection to the ground. So the object now has the opposite charge to the charged object used. So here, like we've seen, when a negatively charged object comes near the neutral electroscope, it repels the electrons in the neutral electroscope downwards into those metal leaves. This causes the leaves to repel one another because they're both negatively charged. So permanent charging by induction and permanent is where you make contact. And this is, you can ground this electroscope by touching the knob here, okay? So when the neutral electroscope is grounded, its electrons are provided with a path away from the repulsive influence. So as a result, some electrons will leave the electroscope, and the leaves will basically return to their normal position, neutral position, because it's kind of, it's overall neutral again. So this negatively charged rod is brought close to the electroscope. The electrons now can leave the metal knob here. Instead of going down, they can leave the metal knob and go to through the person's hand, finger, and eventually into the ground. Once you let go of that metal leaf electroscope, it is now going to be permanently charged. So when the ground and the charged object are removed, the electroscope is left with a positive charge because it lost those electrons to grounding. So the leaves now once again will repel each other. Okay, so when you take that hand away, and you take the rod away, even there's going to be more. These electrons will move back up here, and these metal leaves will be both positively charged again, and then they will repel each other. So this is called charging by induction, a permanent method. The opposite is true for a positively charged object. So when a positively charged object comes near a neutral electroscope, it attracts the electrons to the neutral electroscope. This causes the leaves to repel one another. Okay, so this is a positively charged object comes near, and the electrons are going to be attracted to this positively charged rod, and these leaves become positively charged and the repulsion would happen. Again, when the neutral electroscope is then grounded, okay, there's a path for the electrons to go from the ground into your hands, into your fingers, and into that electroscope through the knob. And as a result, some of the electrons will enter the electroscope. The leaves now will return back to their normal position because now there's electrons that are going to move back down into the leaves. Okay, because now we've got enough electrons, and they're going to repel each other eventually in that knob, and they're going to move down. So when the ground and the charged object are removed, the electroscope is left with a negative charge because it has gained electrons. And now those leaves eventually will repel each other again, because now those electrons will move down into the extra electrons will move down into the metal leaves, and they will become more negatively charged and will repel each other again. And that is charging by induction. This is a permanent method, and I hope that this gave you some more clarification as to what is going on when it comes to when we talk about charging by induction. I think this was the most difficult of the charging methods to understand. So if you have any more questions, please message me, and I will go through with it with you again.